So now that we have all of our shortcut rules down, let's take a look at actually doing some differentiation for various different types of problems. I've got 4 problems up here. We're going to see if we can find the derivative for each one of those. Each one is going to present a different kind of challenge. So let's start up here with this first one. Our problem initially is k of x equals 2x squared minus 3x plus 1 equals 9x minus 1 to the 4th power. So the first thing that I need to do is I need to look at this problem and identify what types of derivatives, what type of shortcuts I need to use to find the derivative for this. So first thing I notice is that there's a product here, so I'm going to have to use the product rule to differentiate this. But there's also over here, when I differentiate this piece, there's a chain rule involved. I have 9x minus 1 to the 4th power. So there's going to be a chain rule involved when I differentiate that piece. So using the product rule, when I differentiate this to start off with, I'm going to get that k prime of x, or the derivative of k with respect to x, is going to be equal to the derivative of the first piece. So this is a straight power rule. The derivative of 2x squared is 4x, minus 3, the derivative of negative 3x, and of course the derivative of plus 1 is 0. So I have, there's my derivative of the first piece. That's going to be multiplied times the second part, so times 9x minus 1 to the 4th power. And then I'm going to add to that the first function, which was 2x squared minus 3x plus 1. I'm going to multiply that times the derivative of 9x minus 1 to the 4th power. This is going to require the chain rule here. So my chain rule, and I'm going to need a little bit more room here, so I'm going to move over just a little bit. Chain rule here is going to require that that be 4 times 9x minus 1 to the 3rd power. There's the product rule, or excuse me, the power rule with the outside function, times the derivative of the inside function, which is going to be 9. So there's my derivative for all of this. I've got everything done there. Now I can do some manipulation, kind of simplify this a little bit if I want to. Both of them have a 9x minus 1 at least to the 3rd power, so I could factor that piece out, and then I could maybe combine some terms. So let's see, if I manipulate this around a little bit, I'm going to get, let's see, there's not much I can do here. I'm not going to worry about expanding that 4th degree polynomial. But I think I will go ahead and factor out the 9x minus 1 cubed. So that's going to leave me with 9x minus 1 to the 3rd power. And that's going to be multiplied by, let's see, I got all of them but 1 here, so that's going to leave me with a 4x minus 3 and one more 9x minus 1. Plus, let's see, I've got a 4 times 9, so I have 36 times, I got all of those, so all I have left here is the 2x squared minus 3x plus 1, and there we go. There's not a whole lot else I can do here. I guess I could multiply these two together and then combine like terms on all this part here, I suppose. That really is just an algebra skill. I'll leave that to you if you want to simplify that further. This is as far as I think I'm going to take this one. Okay, so let's see if we can, let's work a little bit with this second one here. F of w equals the square root of 2w plus 5 divided by 7w minus 9. So the first thing that I'm going to do here, I don't like working with radicals. I'd much rather work with rational exponents. So the first thing that I'm going to do here is I'm going to rewrite this as 2w plus 5 over 7w minus 9 raised to the 1/2 power. And the reason that I like doing that is because that allows me to differentiate that radical using the power rule. Okay. Now I also see I've got a chain rule involved here. I've got a function inside a function. And in my inside function here is going to be a quotient rule. So there's a lot going on with this one as well. So let's go through and see what we can find here. I've got f prime of w, the derivative of f with respect to w, is equal to, let's see, that's going to be 1/2 times 2w plus 5 over 7w minus 9 to the negative 1/2 power. Using the power rule, that's going to move this to from 1/2 minus 1 is going to give me negative 1/2. Now I have to multiply that times the derivative of the inside function. The derivative of the inside function is going to be, let's see, the derivative of the numerator, which is 2, times the denominator, 7w minus 9, minus the numerator, which was 2w plus 5, times the derivative of the denominator, which is 7, all over the denominator squared, 7w minus 9 squared. Now again, we can do some algebraic simplification on this thing, see if we can simplify this problem a little bit. I'm going to leave the algebra part of this, the simplification of the algebra, to you. Just be careful as you're going through the algebra to simplify these things. But this is the correct derivative for this using the chain rule, which involved the power rule, and then the quotient rule when I took the derivative of the inside piece. Okay, so again, not going to worry so much with the algebra here, but there's the calculus is done at this point. I've completely taken the derivative. Next one we wanted to look at here is g of t equals 1 plus sine of 3t to the third power. And so this one again has the chain rule involved. I've got 1 plus 3t raised to the 3 power. This actually has 2 chain rules involved because when I differentiate the inside, I'm going to have to take the derivative of sine of 3t, which is going to involve another chain rule. So this one has multiple chain rules involved in it. So the first thing I'm going to do, I'm going to work outside in. First thing I'm going to do is deal with the exponent here. So my derivative for this, g prime of t, the derivative of g with respect to t, is going to be 3 times 1 plus the sine of 3t squared. There's the derivative of the outside function. Now I have to differentiate that times the derivative of the inside. The derivative of the inside, the derivative of 1 is 0. The derivative of the sine function is the cosine function, leaving the inside the same. But then I have to multiply times the derivative of the inside, which is 3. And so there we have it. We have 3 times 1 plus sine of 3t squared times cosine of 3t times 3. And of course I can multiply those 3's together, giving me 9 out front. Not a lot I can do with the 2 pieces here. We're going to leave those exactly the way that they are. Okay? And again, the calculus is done at this point. If I'm doing anything else with this, it's all algebra anyway. So let's go through and look at our last one here. This one's going to be a little bit more difficult. We do not have y explicitly defined in terms of x for this problem, and so we're going to have to differentiate this one implicitly. So going through here, looking at the left-hand side, I've got a product rule that's going to have to be done implicitly because I have y. And then I have a chain rule here that's going to have to be done implicitly when I differentiate the inside here. So we're going to have to do all the differentiation, then we're going to have to see if we can solve that for dy dx. Okay, so let's start over here on the left-hand side. Again, using the product rule here, the derivative of the first function, the derivative of x is 1 times the second function, plus the first function times the derivative of the second function. That's going to be 2y times dy dx, or y prime, depending on which notation you're choosing to use here. So there's the derivative of the left side. On the right side, I've got to take the derivative of the sine function, which is cosine. Going to leave the inside the same, cosine of x plus 2y. And then I have to multiply that times the derivative of the inside. The derivative of the inside is going to be 1 plus 2 dy dx. So again, there's the calculus is done at this point. This one I am going to go ahead and work with a little bit because we don't really have this solved for y prime or dy dx yet because we haven't isolated the dy dx. So I am going to go ahead and manipulate this a little bit. First thing I'm going to have to do that though is I'm going to have to distribute this cosine over here. So if I do that, and I'm going to simplify this a little bit as well, that's going to get me y squared plus 2xy dy dx equals, and now when I distribute that, I'm going to get cosine of x plus 2y plus 2 times cosine of x plus 2y times dy dx. And now I can move things around here, so I'm going to move, I think I'll move this piece to that side to put all the dy dx's on the right-hand side. I'm going to move the cosine of x plus 2y to the left-hand side. So that's going to get me y squared minus cosine of x plus 2y equals, let's see, I had a 2 times the cosine of x plus 2y dy dx, and then we subtracted out the 2xy dy dx, and then the last thing that I have to worry about here, now I've got both of these terms have a dy dx, I'm going to factor it out and divide by what's left. When I do that, I'm going to get y squared minus cosine of x plus 2y divided by 2 times cosine of x plus 2y minus 2xy. That's equal to dy dx. So that one was a little bit more complicated. The implicit differentiation, that's pretty common for that to be a little bit more difficult to do. But here's some really good examples of some more difficult problems using the shortcuts that we have to work with to find the derivative. We're going to do another video in just a second, working a little bit with some transcendental functions, the exponential and logarithmic functions. We'll get some practice with those in the next video.